As usual, yeah, we're live. Hello, everyone. I'm Nick, and with me, my co-host Ilya. And
Hi, everyone.
Ilya. Hello, everyone. And this is Postgres TV episode 5, right? 5? Should be 5. And today we have very interesting guest, Dimitri Fontaine. Sorry if I pronounce it wrong. Please
That's
correct me.
perfect. Thank you. Hi, everybody.
Hello, Dimitri. And we have a very interesting conversation. I hope today we will divide it to 2 parts. First one will be about SQL versus NoSQL, Postgres side development, and so on. Like when you develop
But not only.
advanced SQL or functions or triggers. We can have a conversation about triggers, like stored procedures and functions in triggers versus ORM and so on.
I think rare chance to blame Dimitri for extensions.
Yeah.
Right. And the second part will be about Autofailover task in general, and particularly about the tool Dimitri is developing, PG Autofailover. Right. So as usual, please, I've noticed our first episodes, I've noticed some people have not subscribed but continue watching. It's prohibited. So if you want to watch, you need to subscribe to our channel on YouTube. And of course, as usual, we will monitor chat for those who joined live. You can ask questions and we will deliver them. Or if you joined Zoom directly, you can join anytime and interrupt any of us. This is the rule. Also, no rules here. Just talk about Postgres and that's it.
Probably you can be unexpectedly muted, but well.
Oh yeah, and maybe banned forever.
There is no rule about this as well.
Right. So I'm very like it's a pleasure to meet you in our show. Let's first talk about like your opinion about how SQL is being developed in general and in Postgres particularly. And actually, usually we start with like how it all started for you, in terms of Postgres, how you started to work with Postgres.
In Postgres,
yeah. So thanks for having me. First thing, thank you very much. I think what you're doing is important for the community and key to this period of lockdown in every country and not traveling and etc. So thanks a lot for organizing and doing all the work. And to get back to PostgreSQL, I started last century, basically. It's a long time ago now. I remember we had the first time I used Postgres, it was at school, because part of the curriculum was databases. And the sysadmin at the time, we were working on a HPUX server with
so it was mostly like a university, not like a primary school.
Yes, university. Yeah, that kind of school. And it was one computer with 32 terminals connected to it. I remember that. And anyway, the sysadmin on HPUX had a very confusing time trying to install MySQL. And then he asked us, would you be okay with installing Postgres instead? And I'm like, yes, of course, please. And but I didn't really know the differences, but I knew it sounded nice. And years later, I got to know that the reason why Postgres was so easy to install and get running on HPUX, of course, was because of Tom Lane. He used to work at HP. So Tom Lane was very, I think to this day, he still have in the attic some HPUX boxes and make sure that PostgreSQL works out of the box on HPUX. So I didn't know at the time, but there was already a link with the community. And after that, my first couple jobs, I was the guy always talking about PostgreSQL and not wanting to use the other technologies. And yeah, I dived more and more into it. And there is something that is very magic to me with Postgres. It is that when you read the documentation and you try what's written on the documentation page, it just works exactly the way it's documented. So you can copy paste and it works and it's exactly what is explained and it makes sense. That's beautiful. We don't have that many software where you can actually have that experience. So for me, it's magic because it allows you to actually invest time and energy and focus into the technology because it just works exactly the way it's documented. So you can try and learn as much as you want.
It means that it means more like property of documentation itself. Like documentation is good, right? Like not Postgres is good. Its documentation is good. No?
Yeah, it's both of them because if it was doing a bad job very well documented, I wouldn't have been interested so much into it.
All right.
It's doing a very good job, and also it's very easy to discover what it does and how it works because the documentation is very nice. And yeah, for me it was the kick, really, the kick to being like using it and to use it more and more and more.
Makes sense. Makes sense. Okay.
Try to screw things up. So we're interested in how you started with that part. So what make you to make a transition from using Postgres towards developing Postgres, which was like years ago, as far as I remember.
10 years ago, you created create extension, right?
Yeah.
This comment, and I actually was reading this blog post, which was written like several blog posts 10 years ago, and I tried to understand how we did it before create extension. I already don't remember how we installed extension, but I do remember because in that post you and also Simon we were referring to the problem when, for example, you have extension, then you get a dump, then you restore, and you have errors. So this I remember very well.
Yes.
I mean, like in 8 something and also in 9.0, a create extension appeared in 9.1. But I don't remember how we installed it all. Contrib modules, I don't remember. This is interesting. So create extension became very natural, and tell us more about it, please.
Yeah, so that's basically the story. At the time, I was using IRC a lot because I had friends in the open source community, and IRC, the relay chat, like it was before Slack and Zoom and all the modern times. But yeah, IRC is very nice, and the community there for Postgres is awesome. And Andrew Girth, Rhodium Toad on IRC, was already there. And so no matter how much you wanted to dive into Postgres, you could ask any question, even on the source code level, and have proper answers and entertaining conversations, and it was awesome. And in parallel to that, I was a DBA as my full-time job, and we were using some very interesting extensions. Some of them part of Contrib, but also already some of them outside of Contrib, like a PGQ and Landiste and other stuff. And as a DBA, my part of the job is, dump and restore should be a non-story. You dump, you restore, that's it. It works. But with extension, it was never the case. So we had PGQ in production, and when we wanted to restore a dump from production into staging, we needed to filter out the PGQ part of the schema and reinstall from the extension each time. And it was driving me crazy. I just couldn't understand why PostgreSQL was so good at what it does, but still PG restore is broken if you use extensions.
Yeah, and the extensibility is one of key features of Postgres, right?
Yes, but at the time it was a key only for developers on the way the code is written and maintained. It was important that you can do some things from outside of Postgres, like PostGIS. PostGIS is the extension that is often mentioned, the biggest example. And it's important to the code organization that you can implement PostGIS externally to Postgres. But at the time, using extension, it was only for very advanced users because it was so hard to dump and restore and do many things around it. So yeah, I got, it's the open source way. So you got a niche, and you try and understand, and you try to fix it. And I didn't realize it would be hard to do, so I just began, trying to write something. It took 1.5 years to agree on the name and 2 visits to Ottawa, just so that in the room we would. So I was invited to the PostgreSQL hackers meeting at the time, and first the task was to agree about what are we going to do, what we want to achieve, and what's the name of it. And it took, basically almost 2 years to get to the name is extension, and here is the list of properties that an extension have, And for instance, it's not the same thing as apt-get, because we have dependencies in extensions, but it's not automatically installed, or at least not in 9.1. Nowadays, some of it can be done, but it won't fetch it from the internet and things like that, and etc. But that took more than a year just to have people in the room have the same notion of, okay, so what is an extension? Yeah.
Like concept, to agree on concept first.
Yeah,
But development took...
Yeah, I'm slowly starting to understand why extensions are like still need some improvements, like proper upgrades within extensions. Yeah, that's
dependencies
probably will take
resolution,
a couple
maybe.
of years.
Yeah, it's hard because the model that we had at the time, and I think it's to this day it's almost the same, is the contrib model. One thing that I really don't like about extensions is that, contrary to most SQL objects, it's impossible to create an extension just from the protocol. So you're on a client, you pSQL to a database, and you do create extension. It only works if you have, before that, installed some files on the server's file system. And some of the files are only possible to install if you are either root or a Postgres. And once that is done, you can do create extension as a SQL command. But what if your extension is only PL SQL files? Like Partman is my favorite example for that. So pgpartman is a very nice extension for managing partition trees, and it's only PL SQL. But you cannot just create extension pgpartman from the client, right? It's only SQL code, but you need to install the file on the file system of the server before.
Right, you cannot package your code and just install it everywhere. For example, on RDS, like if it would be possible, a lot of extensions which are like SQL and PL/PGSQL, maybe PL Python and something. Only it will be possible to install them everywhere. Yeah, it's an interesting thing. Yeah, and what do you think about current state of, like, this is one of things, but like, what do you think? How, like, what is the future of create extension? What do you think about this?
Yeah, so I tried to work on that thing, like for being able to create everything from the client side, but we failed to do it at the time. So that would be one thing, and another thing would be to have the apt-get like possibilities. So I created pg install some years ago. It was when I was working closely with Heroku. So for Heroku to maintain their so they have an extension at Heroku that is a PG extension whitelist. So it allows you to have a list of allowed extension. And if your extension name is not on that list, create extension will fail. And if it is on the list, it will succeed. And there is the equivalent of sudo, so that you can install an extension without being a super user. But
you need to install some contrib package before that?
Yes. Yeah. System. So you first need to install a PG extension whitelist, and then you have that feature set. And the next thing after that I wanted to work on was, I named it PG install. So it's still available on my GitHub repository. And PG install, basically, it's apt-get for extensions. So at create extension time, it will download the binary, install it at the proper place, and then there you go.
But you still need to have a super user access to the database, or?
No, because it includes an extension. So you need to deploy PG install first as an extension on Postgres, the classic way. That's the bootstrap. And after you have done that, you have the sudo capability embedded. Awesome. But only for extensions that are listed as allowed to do that.
Yeah, I've just checked. Postgres 13 allows to specify extensions as trusted, right? Like some extensions. Yes, so yes. Maybe it sounds similar, no? Like similar to.
So PG install, I did that like maybe 7 years ago, something like that. So nowadays, other people apparently are interested into improving extensions. So that's very good news.
Right. Good. Okay. What about, like, let's switch topic maybe and talk about SQL versus no SQL, and what do you think about the future of SQL and current state as well?
we can actually start from the 0 point and then move to this one.
Okay.
0 point is you made a book, The Art of Programming, which is mostly about SQL. So
Yes.
before we are talking about future of the SQL, current state, and so on. So for many people, SQL is something like very outdated thing for the birded old men who do not know anything about JavaScript, React, Golang, and things like this. So why you do this? Why it's actually still actual?
Yeah. So I'm in the context of answering your question. I shared my screen. I hope you can see it. It's the slide with a picture of my book and a special discount for viewers of this program, and it's the discount is available for the rest of the week.
Yeah, and we would not publish it under the video. People just need to watch it through to learn the.
Well, yeah. Thank you for discount. And I've heard a lot of positive feedback about this book. Actually, I bought also several licenses, I suppose.
Thank you. Yes.
Yeah, right. So I also read some parts of it, and it's very interesting. Lots of examples. But again, like why did you decide to write it, and why it's mostly, as Ria said, mostly about SQL only, not about.
So maybe I can show you some simple things that way, like in the slides. So most people, they know to write a query that looks like the one on the slide, like select something from a table, order by, limit 10. And when you talk to developers, you realize that
limit 10 knows not it's advanced SQL.
Yes, and also it's true, you know. I understand you were saying that as a joke, but actually, when you talk with some of the application developers, the question they will have about that is, okay, but if I'm going to implement that in my application, let's say it's Python code. So let's look at here some Python code to do it. If you do it in Python, you want to make sure that you're only using 10 entries for the whole time of the ordering. Like when you sort through maybe 1 million lines, you only keep 10 in memory because you want the top 10. And so you can be very memory efficient that way. Okay, so the Python that I shared, it's doing that with the heap-queue thing here. Oh, sorry, it's not doing what I wanted. So we're using heap-queue, and so it's a queue in memory that it's sorted and only fits 10 elements. So we control the memory behavior. So, but what is the memory behavior? How do you know you're doing a heap sort when you do that? And so it's advanced already, even if with a simple query. But if you've been using PostgreSQL before, you can do an explain. And if you do explain analyze, you can see here in the output that, yes, Postgres, of course, is implementing it as a heap sort, which is a top n, and using 25 kilobytes of memory for the whole duration of the query, even if you have 1 million rows. It's not the case in my example here. But
in Python, you need to program this.
Yes, and to be fair, PostgreSQL needed to program this. And the difference is that it's exposed as a simple order by limit. And that's all you need to remember as an application developer. So it's already advanced enough that we could have a long conversation about that. And for most application developers, they would tell me like there is no way to know what PostgreSQL is actually doing to implement that. And then you show explain analyze, and they're like, oh, but no, I need to learn explain analyze to understand the SQL query. So
or we also now think how can we trust that now it's this, but tomorrow it can switch to different plan and
exactly
don't tell us about it, yes. Right?
And I think it's what's very good about it, because it's easy to write in Python, but then if your data size changes, well, then maybe the algorithm you chose is not relevant anymore. So you need to rewrite the code because now it's a new size of data. Maybe you did write a nested loop for a join, but now the table size has grown, and you should implement maybe a hash join or a merge join instead. Well, if you're using PostgreSQL, you're just using the same SQL query, and it will figure it out for you. So that's beautiful that way, but it can be seen as complex for some people.
So the idea is you should just rely on the experience of dozens of years of development, and that's it, right? Like this is a good idea.
What I like as an approach in general is to get to understand things, and you just don't use SQL because someone told you PostgreSQL was part of the deployment anyway, and it's there, and there you go. I like to see how the data is organized in the database and what kind of processing we're doing. What's the smart way to process the data? Do you want to do some processing where the data is, or retrieve the data first and then do processing where the CPU is? And you know, there is the network in between, so it's not a very easy question to answer. But what I think is very important is to at least realize and understand how much can you do within the PostgreSQL side of the equation, and then does it make sense for you to retrieve only the result, the exact result that you wanted, or do you want to continue processing it on the application, even if you use like 10 times the network bandwidth for the same result set, or the same user result at the end in the web page, for example?
Makes actually a lot of sense. Actually, then some application developer want to get this gradually and learn that. What would be your advice? For example, many people say if someone wants to learn to program, one should learn, I don't know, pointers, recursion, and things like this. SQL is different, it's different level language.
Yeah.
If someone wants to start, what key things one should learn to proceed with learning SQL?
So for me, what you said is the key part of it is practice. You know, it's like I like to compare with learning you know, a musical instrument. Say you want to play piano or maybe the guitar. I think everybody understands that you're not going to be a good guitar player until you've put in the hours, and it's a lot of hours. Before you can play in front of someone and they say, oh, that was a good song, well, you need to practice and practice and practice again a lot. And for learning anything, it's going to be about the same thing. So for SQL, if you want to be good at SQL, there is only one way, really. You do a little of SQL each and every day. So that's why in my book, I have included the database, the data. It's all open data, and you have all the data, and you can play around with it. Because the best way to get good at it is to do some SQL each and every day. And imagine, oh, if I had this question I wanted to answer, what kind of data would I try to fetch? And then you write a little query, and then you arrange the query and rewrite it again and again until you have exactly the result you wanted. I can even share something which is on the fun side a little, but that shows the spirit here. So if I'm going to share again, it should work. And yeah, there is this query that I like a lot. So imagine you're having some data and you want to have a feeling for the distribution of the data in your database. If you write this query, here is the result. It's a nice little trick with using Unicode characters, but it looks like a histogram, and you just have it in the console in PSQL. So you just play around and you have that, and maybe that's the answer you wanted because it was that question, and maybe it's not going to be integrated in a full, you know, reporting application with live updates and things. You just wanted to have an idea of how it goes, and so being able to do this query and get this result in like, I don't know, 5, 10, 15 minutes. Well, not everybody is able to do that. And the difference between the people who are able to do that and the other guys, it's only down to one thing, it's practice. How many times before have you tried to write a SQL query that gives you exactly the result you wanted, and not something approximate that you can filter and finish in the application after that? And so I'm not saying you should do that each and every time, because there is a balance to things always. But being able to decide for yourself, should I continue in SQL or in the application code? I think it's important to have enough appreciation of what you can do in SQL so that you can have the proper answer given a specific context.
So your idea is practice and practice, and that I totally agree. But some Java programmer or C programmer or whatever programmer can say, Okay, that's common thing with one endeavor language. Is there some concepts in SQL which one should definitely know, like recursion in normal program languages? However, in SQL there is recursion.
There is, yes. So I think for me the most important part is the key concept. So you said Java, for example. In Java, when you look at the Java documentation, the first key concept is everything is an object. Well, then you can see if it's true or not, because then numbers are not objects and things like that. But anyway, the main concept you need to focus on when doing Java, it's object and classes and their relationship and how you organize your code around it. If you're doing C, usually you need to understand pointers and memory structure and function calls and things like that. If you're writing Python, then maybe you need to understand also packages, and because the name of the file and the directory where you put it, it's also the name of the package, and then you import the package. So it's important. In SQL, the main thing to understand is a relation. And it's very easy. And most people, even people who are good at SQL, sometimes they don't take the time to step back a little and figure it out. A relation is just a set of data with the same definition. So it means in a given relation, every line is going to have the same number of columns in the same order and with the same data type for each of the columns. That's a relation, that's it. And so, of course, if you create a table, you're going to give it a type, and then, well, the type is the number of columns and the type of each column. And it defines a relation. But if you think about it, any SQL query is going to provide you with a relation. The result of a SQL query is a relation. And for instance, that's why in the from clause of SQL, you can say select from, and people think from a table. No, that's not true. It's from a relation. And that's why you can have subqueries in there or even joins, because what is a join? You take one relation, another one, and you combine them together to create a third one. The result of a join is a relation, and the input is two relations. And if you think about SQL that way, it's all about manipulating and creating relations out of other relations. Then for me, it makes sense. All of a sudden, I can see how it's built inside. So the kickstart for me, if you want to be good at SQL, is understand what is a relation and what you can do with a relation. So union, intersect, except, but then also all the joins, and then order by, group by. What does it mean in terms of defining a relation?
Right, I totally agree. And the question, I have an idea that join is the most important word in SQL because it allows you to create something new. Like, for example, you have two tables, you can join them, you have something new. Do you agree with
new relation? Yes.
You agree with this, right? Okay, and question about, like, back to the book. Would you recommend it for people who just like know very basics of SQL, or maybe not at all?
So for data scientists.
Yeah.
No, it's
I'm
it's
kidding.
very broad. Yeah, I would not, like, main data scientists know SQL actually.
No SQL better than many developers,
many, okay,
actually.
but some of them know.
Yeah.
I met several. So
The way
what do
I
you think
about it is that if SQL is part of your job, then you might appreciate reading the book, and you might learn some things that are going to have some impact on your day job. So,
but I mean, should I start from this book, or should I start elsewhere and then go to this book when I have understand more?
Sorry, I misunderstood the question. Yeah, we don't in the book I don't answer all the beginners' question about SQL. Okay. So if you've never done any SQL before, or if you don't know which tool to use to do SQL or how to install Postgres, the book is going to be starting way too fast for you.
So it's like medium to advanced level
yes,
in
exactly.
terms of SQL knowledge.
It's for people who already do SQL regularly, but like, oh, maybe I'm missing out on some things. I should dive into it for real. That's the yeah.
Do you have any suggestions actually which can prepare completely beginners for your book? So maybe some tutorials, some online courses or books. Is there something?
It's interesting. I'm not sure really. I remember this website, PostgreSQL exercises. where you can do interactive queries and discover the basics. And it's nice because you don't have to install PostgreSQL yourself. It's online and you can play around with it. Because I think it's like when you discover a new programming language, right? So most often you need to discover also the tool set that goes with it. The compiler, where is the online documentation, how to compile the code, how to execute it, do I have an interactive debugger, and all those things, the IDE, and it's non-trivial. So if you wanted to get started with Java today, it's not the same thing as I started in Java like with version 1.1 or 1.2, something like that. And at the time you edited a file in Emacs and that's it. But nowadays, if you want to do Java and use advanced libraries and things, you need a lot of tooling and support around it. And it's very well advanced. So that you need to learn the tools and then you get good at it. With a SQL, we don't have so much advanced tooling, but still, if you've never done a SQL query before, you need to install a database, create a schema, a table, put data in the table, maybe normalize the schema so that you have multiple tables, and then it's meaningful to do a join. And all those steps, it's important, but it's hard to get started from scratch.
Mm-hmm. And the question about things like there are two very opposite points of view. One is business logic in Java or anywhere else, and another it's like, oh, I just realized that if we manipulate data right on database side and only produce result, so we write functions or triggers or both, it's much more powerful. Let's do this, and like let's put all business logic on database side. And of course, first types of people, it's much more like more popular point of view. This point of view is much more popular, or RM are everywhere. But second type of thinking is also makes sense, right? What about you? Where are you?
I have maybe a slightly different view on it. My thinking is that as soon as you query a database, even if you do like select star from table, and then you do everything else in the application. Let's say you have a use case where it makes sense to do that. I've not seen a lot, but let's say you have it. Well, then the fact that you select star from a table is already a kind of a business logic. Because you're not selecting from another table, it's that one, not another one. And you're selecting all the columns because somehow you need all the columns for your later processing. So you've made non-trivial choices already. You didn't select this column or this value, and you didn't restrict the table to where ID equals something. So even the simplest query, it already embeds some decision-making you made. Why did you write this query and not another one? So it's already a part of the business logic implementation. Whatever the query is, however complex it is, it's already some part of your business logic. A part of your business logic is already written in SQL. So for me, the question is not, do you want to have your business logic in SQL or in the application code? For me, the question is, how much do you want to push on the server, on the data side within SQL, and how much do you want to keep on the application server? And the answer to that question, it can make sense on several levels. It can be because it can be more or less technical. Maybe you don't have the knowledge to do it in SQL, so of course you're going to do it in the application server. Maybe you know how to, but then your review is going to be hard because you're the only one in the team who knows how to do that. And so there is the question of team organization and how to share knowledge, and it's non-trivial. And there is also the network bandwidth. If you retrieve too many objects, maybe you're going to clog the network. But if you're using too much of the CPU power on the PostgreSQL side of things, maybe you cannot run very high concurrency, and then you have a problem. So it's not easy to say you should do it that way or this way. I think what's important is to understand that any SQL query is going to embed some of the application business logic. You don't have a choice around it. The choice you have is how much of it makes sense. Because if you're going to talk to the database, how much of the workload you want to have it solved for you in the database? So,
Yeah, interesting. So it's not a black and white. It's like you have a slider and you need to choose.
And
exactly.
keeping that in mind, which actually, from your point of view, limitations has SQL and particularly SQL and logic on the side of the database? There are some limitations, definitely.
Yes, yeah, there are limitations. When I have to design that kind of approach, what I try to focus on is the transaction boundaries, because some of the processing, it needs to be happening in a single transaction. For instance, the default isolation level in Postgres, it's read committed, which means that if you do two queries one after the other, you might have even the same query twice in a row, you will have maybe two different results. So if you select count star from a table and someone else does an insert, and then you select count star again, the count is +1. Okay, that's pretty obvious. But if you're running a financial report, do you want to see the +1 in between the two queries? If you had computed an average and then you compute something else, do you want to see the +1, or do you want to continue with the snapshots that you had before? And you can, in PostgreSQL, very easily say, I'm going to run several queries and they're going to use the same snapshot of the database, please. It's like what pgdump is doing. And you just say that your isolation level is serializable or maybe a repeatable read, and that's what you have. But it's not the default, so you need to think about it. So for me, that's the first thing, like what kind of transactional behavior do you need in this part of the application? And usually that's rather than going to repeatable read, maybe you can write a SQL query that is a little more complex, more involved, but it's going to do all the processing in one single query, which means you don't have to think about isolation level anymore because it's doing everything you need in one go. So my personal excuse for writing complex queries, usually it's bound to round trips and also transaction boundaries, because one query is one transaction and one snapshot by definition. So you remove all the complexities about thinking about that. It's only one query.
Are there actually some cases when you definitely wouldn't advise to use SQL on the database side to implement some business logic?
Yes, but that's a software architecture, right? Like, do you want PostgreSQL to be your cache? And so back in the day, you might remember about that Apache mod libpq.
Yeah.
Yeah, so it was a Apache module that you could use, and basically your URL, it would get the components of the URL and transform them into a single call of a stored procedure. So
there are several things, actually some more modern implementations of this, yeah.
Yeah, some people still do that, yeah. So you have a URL, it calls one stored procedure, and the output of the stored procedure is the HTML page, the output.
It was like in the era when JSON didn't exist. Right now there is Postgres. It's doing almost the same. You have HTTP request, get or post, and the result is JSON. Like, it's very similar, right?
Yeah, and then you can format JSON on the browser side in JavaScript, I guess.
With React or something, right?
Exactly. Yeah. But so
you wouldn't do this.
Sorry?
So you wouldn't do this?
Depends. I've been on a project where we would do that actually, because it was for advertisement server, and basically the job was to find which advert to display. So we had a query as input, and the output was one single URL, And so the integration, the whole application stack to choose which ad to display, it was one single SQL query. So it was like 70 lines of SQL, but it was one query was the application. But that's a very specific application, and it's not about SQL that much. It's about software architecture in that case. Like, how do you design your software? So I think it's I think it's a very tricky question to answer in the general, because there is no answer that makes sense for everybody. It always depends on exactly the context and what you're trying to achieve.
Right, but there are definitely dangerous parts. For example, if you build such kind of application, and for example, you want to call some API, for example, I don't know, like Zilio or Stripe or anything.
Yes.
In this case, this approach like fails very quickly when you scale, because on your master, in your transaction, in your function, you need to wait until that external API works, and any delays are very dangerous, right? Or also, for example, we need to save a file or picture or something. It's also like.
But the way I try to think about it is more like transactions. So if you're going to call an outside service like Stripe, they're going to have their own transaction. And basically what you're saying is that this transaction is now part of the SQL transaction itself. And as soon as you do that, you open a lot of hard questions. Like, what if the Stripe connection fails? Do you want to fail your PostgreSQL transaction? Same if you're writing to a file system is full. Do you stop Postgres, like the transaction in Postgres should roll back, or do you want to commit it and process it later? So for me, it's like
even worse if it doesn't fail and takes time, or fails not quickly.
Yes,
this is a problem. This is where we slow down and like I like this approach, transactional approach. Like think about it as a transaction and what do we want. And I think we like in Postgres we don't have autonomous transactions like in Oracle, right? Oracle has it.
Yes, we have some kind of it in if you do procedures rather than functions, you can use call, and within a call to a procedure, then the procedure is allowed to commit in several parts. So you can have more than one transaction within a single call statement.
Right, but it's not the same. Like for example, we need to call external resource.
Yeah,
it would be good to have another transaction which will be separated from us, and then we will later check its status, something like this. But it's not easy right now. You need to use like DB-link or some queuing mechanism, PGQ maybe, or something. And
so I used to use PL proxy for that, for the very naive version where you just want autonomous transactions. So PL proxy is good at that. But
you only have option to use it in auto commit mode then.
Say again, sorry?
But with PL proxy, you can use that only in auto commit mode. So you cannot use autonomous transactions with manual rollbacks and so forth.
So what you do, you have a store procedure that is calling another one, and the other one is called via PL proxy. So the embedded transaction, it may commit or roll back, and you get the information back from the caller, but thanks to PL proxy, it could be DB-link too. It happened on another transaction, and so then you can have the result and decide what's next, and your transaction is still safe to proceed. But it's very strange. I like it better.
We're slightly shifting to problem of distributed systems, actually.
Yes, exactly.
And for example, what if, like, okay, with DB-link or with this approach with PL proxy, if my like dependent transaction already committed, but I need to roll back, what to do?
Exactly.
Like, lack of two-phase commit, right? So without two-phase commit, but two-phase commit is slow, of course. So like it's not simple at all.
Yeah, because you have 4 messages minimum per transaction with a two-phase commit.
It's, you sound like a person who implemented Autofailover.
we do use some two-phase commit in PG Autofailover, in some places. So yeah.
Yeah, I think we're moving slowly towards that topic from SQL.
Before that topic, I remind that please ask questions in YouTube or in Zoom if you can, and if you have questions anytime. And I have a question, like before we switch to Autofailover topic. I've checked yesterday, and today is exactly 1 year since your latest post in your blog.
Oh. Wow. Okay.
So congratulations, 1 year anniversary. But when will you continue? Because blog posts are very good old ones. We need new ones.
Thank you. Yeah, I should do that. Also, so I've never said it publicly, so it's a first on your show. You know, when I wrote my book, I had too many ideas, so I had to cut down the list of topics I wanted to address to fit in one book. So there is this idea also that I have in my mind to write the next volume of the book. It might turn into a series, and that would be my excuse to get back to blogging, because usually it's a feedback loop that I like. Writing the blog posts, it gives you a very short amount of research and time to publish it, but then piece by piece you can turn that into enough material to then have to write the book. So,
interesting. So you publish blog posts, collect some feedback, improve it, and then it's material to build, like to accumulate.
And also, yeah, because writing a book you need a focus for a very long time. Right. But for a blog post, usually you do one blog in a post would be written in, like, I don't know, 1 hour, 4 hours, maybe 2 days, but not more than that. It doesn't make sense. And so you need to focus very strongly on one small thing to share with the readers. I like that exercise, and that way you can build up a table of content, and then you have a material for the book. Yeah.
Good recipe.
It's a nice recipe.
Yeah. Well, it's not so good, because when you then go to write the book, you realize that it's not written the same way at all in a book and in a blog post. So you need to rewrite everything. But at least you know what to talk about.
Yeah. Did you think, like, I will ask another question in this case. Did you think to make your book like maybe an interactive, or did you consider, or maybe like some course, educational course when because you have a lot of exercises, and like not exercises, examples. They're not exercises, they're examples in the book, right?
Exactly.
Did you consider to convert them to exercises?
I didn't have time yet, but I would like to work with an application developer and do the interactive version of the book, where you can click on any query, run it, and then modify it and see what it does, and things like that, and play with any query in the book. I think I have 365 queries in the book, and I have unit tests for all of them in my publishing process. So I know they work, and I have the data set that goes with them, etc. So with that, it should be easy not easy, but it's possible at least to write an interactive application from the book. So yes, I would like to do that, because then you don't have to learn how to install Postgres. You can just click on the query and play with it.
Exactly.
That would be very nice. Yeah. Maybe another last question before we move on to the Autofailover, because we tried to put on this topic right in the beginning, but we immediately moved into the deep dive into the SQL. So what, from your point of view, is future of current SQL? Where it goes, what you want to see in SQL language, PostgreSQL language in 10 years, or maybe even...
That's a very good one. So there is one thing that is in the standard. In the SQL standard nowadays, it's a SQL 2016, the latest, I think. And there are a couple of things in there that we don't have yet in Postgres. Match recognize is one of those. So basically, you can do it's like doing a regexp on the output of a query, but you compare rows. So for example, you could say with the coronavirus, we all see curves where it goes down and up again. And so you could write a query very easily telling, find me the days where it was improving, and then it's increasing again. So I want several days in a row that go down, and then one day that goes up from there. And with a match recognize, it's very easy to express that as a SQL query. Without it, it might be possible with window functions and stuff, and it's a little advanced. It's still possible, but you cannot express, I want to go down and then up, and I want to see the first row that goes up and the difference between the previous one, etc., etc. And I want 5 in a row that goes down before it goes up again. And you can express crazy things that way with a match recognize. Marcus Winand has a very good slide set available on his website, modernsql.com. And another one is Vic is working on it. It's the system periods from the SQL standard. So where you can say that you can add, basically a start and end date to any value in a table, and the value is only valid within that period of time. And you can have different kinds of it, but something that is very nice, for example, if you update the value of the column in the middle of the date range, it will create the 3 ranges for you: the first, the middle, and the end, because you update it just during a period inside the existing one.
Standard was complex 10 years ago, but right now it's already like too many things.
Yes, yes.
Have you heard they stole abbreviation from Postgres, PGQ? The new part of standard is called PGQ, and it's about work with graphs. So,
okay, no, I didn't know. Okay.
So there is SQL/PGQ, and yeah, it's something very new. So yeah, it's and it's interesting, and I think the topic of standard is very broad as well, because no database system supports it completely, or like
yes, yeah,
like it's very difficult topic. But I also like when you mentioned documentation in the beginning of our call, you said like documentation is what explains very well, and I like that many parts of documentation refers to standard, like
yes,
some explaining deviation from standard, and like it's very also like it's also good. Okay, let's talk maybe about Autofailover thing. First of all, why did you decide to create it, PG Autofailover, and what's the purpose for which projects it exists for? And
so I'm going to share my screen again, just to show that it's the first architecture you can do with PG Autofailover. And so because you guys, the host of this show, you know what it is to implement HA in Postgres, and you've done it many times before. So you will witness, first thing you see here, it's not HA, right? It's not providing you with HA because you have a single standby. So if you lose a standby, what's next? And that's why we did a Autofailover, basically, because our customers, they wanted to be able to failover when they lose the primary, but they didn't want to have 2 standbys. They wanted to have only one, because if you're using Citus, for example, you have 1 coordinator, and then you have 4 workers, let's say. So that's 5 nodes. That's a very small cluster size. And then you want to have HA for them. So if you need 3 PostgreSQL nodes per instance, now your budget is going from 5 nodes to 15. And when you scale up, let's say you need to have 5 other worker nodes. Well, no, it's 15 more. So you have 30 servers to take care, and just to have HA. So in terms of budget, the question that we were asked is it possible to have something good enough already with only 1 standby per node? What can we achieve with only 1 standby?
Let me stop here a little bit. It's interesting thought. Like in stateless applications, we in many cases we are good with 2 nodes, because it's if one fails, we fail over to another, or even we balance work between 2 of them. But if one fails, we can quickly replace it. With stateful applications, it's not so. That's why usually we talk about 3 nodes, because if we lose 1 node, we have only 2. It is already feel very dangerous. We need a 3rd one, but it takes time, right?
Yes.
So yeah, I agree. This is interesting. Yeah, I didn't think about it from this. It's very basic, but for me, it's like I didn't think about it in this perspective. But so that's why we need 3 usually, right?
Yeah, we need 3 because we want to have a good trade-off between availability of the service and availability of the data. And if you want to have both, like keep the service running and never lose any data, with Postgres, there is only one choice. It's 1 primary and 2 standbys. So you cannot achieve a good trade-off with the availability of service and data with only 1 standby. The only thing you can do is, if the standby is running fine, you support failover. You can lose the primary at any time, and you can promote the secondary because it's there and it's working fine. But if you lose the secondary, then you need to decide, do you want to stop accepting writes? Because there is only one place where they go, it's the primary, that's it. You don't have a secondary anymore. Or do you want to allow writes, but then you don't have a failover? So in PG Autofailover, well, we want to have a skew towards availability of the service. When you have only one standby and you lose it, we disable synchronous replication and we accept writes so that your application works normally. It's just that because you lost a standby, you've lost the ability to failover. But it's the application is allowed to continue working normally. So it's somewhat dangerous. You need to pay attention. If you lose a standby, you need to put another one or repair it quickly. But you know, there is no trade-off that is going to be the perfect trade-off for everyone. So that's the trade-off that we made with the first version of PG Autofailover, and it was the only supported architecture for a long time. So if all you want is failover, that's good.
Right, and again, this is in the context when we're talking not about only one primary. We have many primaries because it's about, like you mentioned, site or so. It's about sharded database already. So we have some risk of losing some writes for one shard only, right?
Yes. So that was the background in which we designed that. Mm-hmm. But in reality, we have many users who are using PG Autofailover. They are happy with it with only one standby and with just a normal PostgreSQL workload. If you think about it, my colleague Ozgun, he likes to remind us about that. The Heroku model, where they have millions, they grew up to 1.5 million production databases in Postgres. And they only use async rep and one standby. And they have 1 million happy users with that. So I'm not saying that every application will be happy with that, but I'm saying it's an architecture that makes sense for some people and some use cases.
I would say maybe most of our clients are actually working like this.
Also, there are cases when there are many replicas, but there's no any autofailover solution at all because infrastructure is so good that problems don't happen for years. I also know such cases, so it's like
yes, it's always some sort of very funny calculation when we calculate high availability. It's like how many time we can spent off the servers during 10 years, for example. And one single failover with like normal manual failover can make us like wait 10 seconds or a minute during those 10 years. And one unsuccessful autofailover can actually cause very, very interesting effects, like
and cost a lot.
GitHub, I believe, did that. Like it was several days outage, and they lost actually one standby, then another standby, then another standby, and it was like. Did you think actually to implement some mechanism in that direction, how to avoid improper use of autofailover? Then you are risking to lose lots of standbys and then basically run into problems.
Yes, but I'm not sure. So I'm going to tell you what we did, and you're going to tell me if that's a good answer to your use case, because I'm not sure I understood everything.
But before you tell us about new picture, how is it possible? Like millions with just one standby? I suppose it lives in AWS, right?
Heroku, yeah. So Heroku has more than 1 million users, and each user will have one database with only one standby and async.
But it's like on which platform? AWS, I suppose.
Yeah,
right. So
on top of AWS.
There you can easily lose instance at any time.
Yes.
So it means that
so we are talking about mathematical expectation of this event, and it's slow.
Clusters right now. A lot of clusters have only one node.
Yes, the thing is, if you have the budget and you have a DBA team and you know what you're doing, and in some cases, it's, for example, you cannot lose any single transaction. And each transaction is very valuable. So maybe this architecture is going to make no sense at all for you. But in other cases, for instance, advertising, it's so cheap to display one ad that you don't care if you lose transactions. You want the service to be back, and you want to continue advertising at all costs or almost. And if you lose 1,000 or maybe a couple thousand of transaction which says you used another cent of the budget, well, you're going to display the ads 2,000 times more than the contract said. So no client is going to fire you because of that.
Right. But here I feel like we're mixing topics a little bit, because losing rights, it's about like maybe having backups or other replicas which already got like propagated for those rights propagated. But lack of like just one single standby which can be down, it's about increased risk for HA, because like
Yes.
downtime can be increased if both nodes go down, which probability of this is not zero, of course. So
Yes.
And
So,
we don't have third node at all.
yeah.
And so this is also like interesting question, because I know like Google had this paper about like two nodes is definitely on this scale, millions, two nodes. It means that you have situations when you cannot serve even read-only queries.
Yeah.
So this is tricky a little bit for me to understand.
So the way I like to say it is that if you only have one standby, you don't really have HA.
Right.
You have the capability to fail over in the IP case when the standby is still there, etc. If everything goes well. So the other way to say it, it's the way we have written it in our documentation is with this architecture, we are resilient to losing any one node. If you lose the monitor, no impact. If you lose the primary, fail over to the secondary. If you lose the secondary, we disable sync rep so that you can accept writes on the primary. So you can lose any one node and it's all fine. But if you lose two of them, we cannot help you anymore.
You are losing a whole shard in this case.
Yes, exactly. So then it's up to the user to decide if they are going to be okay with the...
To save money, of course, right? Because this is decision.
Yes.
Because based on budgets. Okay.
Yeah, budget, money, or the nature of the data that you're handling maybe in your database. Because maybe it's not financial transaction, but maybe it's maybe it's not the end of the world, and maybe you can rebuild the data set. I don't know. It depends on the applications. So
makes sense. Okay.
So it's to be seen as a flexibility, and we're not trying to say that's the main use case you should have. No, not at all. We're trying to say if that's something you want to do, the easiest way to implement it nowadays, it's PG Autofailover. It's like 3 commands and it's running and it's in production, and it behaves like we said. You can lose the primary, fail over to the secondary. If you lose the secondary, you need to replace it, and it's fine. But if you want HA, then you need more than one standby. You need 2 standbys or maybe even more. So we have different ways to do that in PG Autofailover. And to get back to Ilya's question, in PG Autofailover, every node has 2 properties. You might be able to read there if it's written big enough: replication quorum and candidate priority. So candidate priority, basically the one with the higher number is the one we want to fail over to. Okay, so that's easy. And replication quorum is, do you want the nodes to participate into the synchronous replication or not? So it's true or false. And there is a trick with candidate priority, which is you can have candidate priority of 0. And in that case, the node is never going to be a candidate for failover, whatever happens. Even a node in the system that is a standby, and for example, you use it for reporting queries or read-only queries and things like that. And you know that the server is not meant to handle a production workload because maybe it's only there to have an extra copy of the data to do this kind of reporting that is important and you offload from production. but
Or
it's
you
never going
probably
to be
can
a candidate.
reserve some server to make DBA come see what happens and to do that manually if Autofollower scenario doesn't work.
I missed the beginning of the question. I'm sorry.
If for example you have some sort of standby which doesn't mean to participate in Autofailover, that probably could be reserved standby, which DBA can promote manually if everything else failed before.
Exactly.
If
Yes.
Autofailover works.
So a classic way there. So the images here are taken from the documentation, right? So it's not every possible architecture, it's just a select number of them. In this one, for example, node C in the middle, it's not participating in the quorum. So when there is a transaction that commits, we don't care if C has it or not. We don't wait for C, never. And candidate priority is 0, so it's never going to be promoted. So maybe node C has been deployed in a separate availability zone, right? So this guy is never going to be automatically selected for a failover. But if that's all there is left, because you lost the whole availability zone with node A and B and D, well then, like you said, Ilya, you can make it the new primary. You can promote it and you can start again from the backup AZ.
Like plan B.
Yes, it's like not the
C.
word, but you still have a copy. Yeah.
Yeah.
So it's usually we call that a disaster recovery plan. So if you have a big disaster and you lose a full zone, what's next?
Yeah,
with Autofailover, it's very easy.
Possibility, yeah.
Yeah, it's very easy with Autofailover to register a standby and say, okay, this guy, you never fail over to it, whatever happens. But then, like you said, if the worst happened, then yes, you can do it manually.
And actually a question which is more about not the ideology and architecture of this thing, but more towards implementation. Quite successful solution, for example, for Autofailover as well is, for example, Patroni, which is quite well known. And Patroni is a good example of the sort of a toolbox. So it's basically not a solid piece of software. It's just a thing which collects different tools which allow you to do this and that. And that's very typical modern approach. If we take a look on the PG Autofailover, it's like a solid C program, like PG Bouncer or Postgres itself, and it's written like Postgres. What's the reasoning behind of that? I would probably expect that you will write it in Lisp and will manage some another tools like Patroni does. Why?
So there are several answers to that question. So it's written in C with the PostgreSQL license, so that when the time comes, if it's interesting, we can contribute back to the community, to Postgres itself. Maybe we will have some features at some point that Postgres wants in core. And this discussion can only happen when what we do is written in C with the PostgreSQL license. So that's what we did. And so the discussion is open. It didn't happen yet. There is no reason yet to do it, but it's something that we are ready for. And then, contrary to Patroni and other tooling, my vision with PG Autofailover, if you want, is to fill in the gap that we have in Postgres. If you know how to use Postgres, like yourself or Nikolai and other experts, you can do basically, you go to a customer, they explain to you what they want to do in production, the kind of HA they want, the kind of SLA they want, and their budget. And you're going to draw an architecture and you know how to implement it. But most people, they don't have this knowledge. They don't know that PostgreSQL, for example, you can have in the same system at the same time the transactions that are going to be synced to two other nodes and other ones that are going to be written locally only. And you can have that in parallel. They don't know how to make it so that when there is a failover, you PG rewind the standbys. And maybe that when you do a failover, because you have two standbys, one of them, or the two of them actually, they need to have a physical replication slot that you advance every once in a while, so that when the other secondary, rejoins, so one secondary is no primary, The other secondary is still a secondary, and it connects to the new primary. And how do you make sure that the wall is still there on the new primary, and it can continue exactly without interruption, if you mean? So the only way is to have a replication slot that's ready and that you advance once in a while, so that when it connects, it can continue. If you don't do that, you need to do a PG rewind. And if that fails, you need to do a PG pass backup, and etc. So you know how to do that. Nikolai knows how to do that. But most people that want to run PostgreSQL in production, they look at the documentation and they are overwhelmed and they don't know where to begin to implement HA. So my vision with PG Autofailover is that if you want to do that now, it's 3 commands, 5 commands, depending on the number of nodes. So 1 command for the monitor and 1 command per node. And that's it. It's ready for production. And you can implement your own architecture with your own trade-offs. And when failover comes, it's going to do all the things in the right order. With the slots are there, they are maintained. It knows how to PG rewind if necessary. It knows how to PG pass backup if that's needed, etc., etc. It's all so it's a real product and application. It's not just a toolkit.
So it's something in between, actually, between basic PostgreSQL tools out of the box, which are for sort of advanced users, and Patroni, which is for advanced DevOps users, and somewhere in between is PG Autofailover. Yeah,
my dream is that someday people who want to play around with Postgres and they don't really know how it works yet, they would just use PG Autofailover, run 3 commands, and their production is running. And maybe within a year or two, they will have more knowledge. They will understand better their expectations, and they can change the trade-offs they put in production. And maybe, if needed, they can even change tools. But at least it was easy to get started.
Okay, you know that I'm skeptic, right?
Yes, I know that. I'm waiting for your question.
I still don't understand why not Patroni or other tools. And from what I hear, it sounds like maybe like replication manager, which already exists. And it also, you have some common things. For example, not using consensus algorithm written in C, using some extension, or maybe I'm wrong here. PG Autofollower has some extension to be installed onto Postgres, right? Or no?
Only on the monitor.
Right, monitor.
So
this monitor.
Yes, it's a PostgreSQL extension.
Right.
But on the nodes where you run your application, you don't need to install extra things. It's a vanilla Postgres.
Right, but it's okay. But it's like, why not a replication manager in this case? So if like for basic setups where we have only 1 or 2 standbys.
Several things. First, there is one question that we are not there yet with PG Autofailover, but it's part of the plan. I've met with DBAs that they refuse to use automated failover in production, because usually when you implement a failover, then you need to reconfigure all your backup and recovery, and you need to make sure that you didn't lose any wall in your backup system, in your archiving, and that's non-trivial to do. And that's something that I want PG Autofailover to take care of later, like have the option to say archiving is included.
Regardless of which tool is used, like WolG or PG Backrest or something.
So PG Backrest is very good at backups. And for me, backups, it's like if you're a bank, you need to ensure that you have 30 years of backup, whatever happens. If you are in the HR department, it's 50 years, because a career, usually it's 50 years. So if you're handling payslips, you need to make sure you have them for the next 50 years, and you don't have a right to lose them. So that's backups. What I'm after, it's not backups that way, it's disaster recovery. It's make sure that you never lose a whole file because you just did a failover. PG Backrest doesn't do that. Rep Manager doesn't do that. Patroni doesn't do that. It allows you to do it, but you need to be an expert to know how to make sure that you never lose the whole file.
Okay, in this case, why not Barman, which is based by default?
It's not disaster recovery per se.
It's as I know, Barman can use, and this is like which distinguishes Barman is that it uses replication connection, so it receives everything.
Yes.
And you have.
Here is the trick question for Barman. When you do a failover with Patroni, what is the impact on your barman configuration? Is it zero impact, or do you need to reconfigure barman after a failover?
I guess you need, of course, because barman needs replication slot. It's barman, like if we want to marry barman and patroni, it's interesting topic.
Yes.
Probably should ask Kukushkin about it. But barman is for master for the primary. It feels like a replica, right? With replication slot.
Yes.
So I guess patroni could control it, and any autofailover tool could control it. But like, still, why not replication manager, for example? I don't understand.
Yeah, rep manager. I think
complexity.
My goal is to have a tool that is simple and robust, just works in every case. It does something very simple, like failover. That's all we do. Autofailover. We automate the failover. That's all we do. And
so you basically you're not intend to make easily reinstantiating the standby, all the things which rep manager does. So like sort of all working with replication. So just failover.
Yeah, but have you seen how to implement a manual switchover with a rep manager? Did you see that part of the documentation?
Not only seen, participated in like helped to do it. So it's of course a task.
So the first thing you read in the documentation for a manual switchover is basically don't do it. It's dangerous. You will lose data.
I think they improved it recently, but still I'm against the replication manager. I'm against it because I saw how it feels when you have split brain many times.
Yes.
So and with replication manager,
so that's why.
But that's why I'm asking, like, why? Because I feel that you go in the same direction as application manager, not using.
The big difference is with the first. So let me. Where is my cursor? Yes. Okay. Share screen again. I think it's there. Okay, there we go. So let's go with the one primary, two secondary design.
Mm-hmm.
We have the monitor, and we have an implementation of a network split protection, and split brain is prevented too, thanks to the monitor. And it's not something you add to the design. It's not an optional part of the design. It's the art of the Autofailover design, that the monitor is there because you need to be able to differentiate between I lost the network connection to the primary and I lost the primary.
They're a typical Byzantine fault tolerance problem.
Yes, and you cannot do that if you have only primary standby. You need 3 nodes to be able to recognize that. And you need 3 nodes, but also you need a careful implementation that will do exactly the right thing at the right time to make sure that you never have a split brain. And Rep Manager is famous for being difficult to set up, or it's too easy to find a bug in Rep Manager around that. And that's also why we don't use it. And that's also why our architecture is very different.
And this monitor, it's a separate node that should sit where? Like, for example, we have primary in one availability zone and secondaries in 2 other availability zones. Where should I put monitor?
So it may depend, but usually you put the monitor in the same zone as the primary.
But after failover, it will change, right? So should I move monitor?
So for now, the classic target that we have is failover within a zone. If you want to failover multi-zones, then basically you promote the standby in the new zone and you reinstall Autofailover on top of it, because your previous zone is dead anyway, right?
It sounds like you implemented monitor because it's the only one. You implemented that as it is because it's the only one way to make it reliable. Like then you have one monitor, you are reliable. It's like default in distributed transactions. But it sounds like at some point you probably will move to several monitors and consensus between them. It's like many people want this.
But in this case, like if you do this, definitely there will be another question: why not to use etcd Zookeeper console, which already implement and well tested? Etcd is well very well tested.
Yeah. If we get to implementing distributed monitor, like more than one monitor, we will at least use Paxos or Raft, and maybe use just etcd or things like that. Mm-hmm. So when we started PG Autofailover, our customers, they never used etcd, Zookeeper, or anything like that. And it's a very complex discussion to have with them, that you need to deploy at least 3 nodes, because less than that and you don't have the guarantees that you need, but not more than 5, because you lose availability after that. And it's a whole topic of its own. So if you're already running etcd in production, maybe the easiest way around is to use Patroni and connect to it.
That's most
but
common
then you need to think about discretion too. I'm sorry, Ilya.
Oh, I'm just confirming your point that that's the default answer. Then people asking which sort of software to use, etcd or whatever.
Which already you use.
Which you already are using in production. Yeah.
If not,
if not,
there are other questions like maintenance of this.
Yeah. So it's complex in its own right. But then again, you need to realize also something as a user, is that the leader election mechanism and all the advantages of using Paxos or Raft, it only applies to the consensus nodes, right? And in most of the architectures that I've seen up to now, the nodes that are participating into the leader election mechanism, into the Paxos consensus group, it's not the same set of nodes that are actually running Postgres. So the fact that you use Paxos, it doesn't prevent split brain. It doesn't help you at all. It only helps you to have a monitor that is always available. So in PG Autofailover, if you lose the monitor, we can continue to function. The program will not crash or stop. It will just wait until the monitor is back alive again, or the network to the monitor is still available and things like that. We don't just, there is no incident when the monitor is down. It's part of the lifetime of our solution. You can even do upgrades while everything is working.
Yeah, it makes sense. So you just lose a capability to have, you lose this feature for some period of time.
Exactly.
But what if
is that the monitor is a spot?
What if this happens? We have primary and secondary in one partition of network, and monitor and secondary in another. Will monitor promote secondary?
So, oh, nice. So, you drew.
Yeah, I've drawn here the line right here. Yes,
that's perfect. Let's keep that. So in that case, so what will happen is that we will fail over to the secondary.
Right.
Only after 30 seconds, there is a timeout. So the situation needs to last for at least 30 seconds.
Okay.
And so we need to focus a little. It's a little complex, but node A, the current primary.
Mm-hmm.
We have PGAutoCTL running there, and it's not able to contact the monitor, right? 30 seconds in a row. And when that happens, the primary will also check for, pgstat replication entries. Okay. The idea is, the question is, am I completely alone on the network, or is the monitor down? You need to differentiate. So we look at
why
information.
Why do we need that?
Because the choice you need to make on the primary is either to continue as a primary,
mm-hmm.
or to resign and stop Postgres.
Right, exactly like we discussed. If we just lost monitor, we don't want to do anything. We just want to repair monitor. Okay.
But we need to understand that it is exactly that case, because we can lose monitor, or we can lose just a network between primary and monitor.
Exactly.
Which is going to be promoted separately, which feels like split brain already.
Yes.
Right. So how can we understand how PG Autofailover can?
Yeah. So you need two bits of information. You need to know: can I contact the monitor, and can I contact the other nodes of the system?
Okay. So
if it's only the monitor that you cannot contact, you continue as before. Mm-hmm. And the other nodes, you are connected to them by looking in pgstat replication, because in pgstat replication there is one line per standby. And if the standby is not connected, there is 0 line, right? So you count the lines in, well,
which means which means that we can use only streaming replication in this approach, no whole shipping based application.
Exactly.
Right?
It's
Okay.
based.
This is a requirement in this case. Okay.
Exactly. Yes. Yeah,
because we are talking about high availability as a primary goal.
Well,
to be completely honest.
Well,
it's a design choice. I mean, you might have a different one, and we could argue about it. But yes, in our case, it's a streaming replication only.
Okay. Okay.
So it only works that way. So we look at pgstat replication. So remember, we couldn't connect to the monitor several times in a row. Now it's been 30 seconds. So we look in pgstat replication, and if we see that no one is connecting to us, and for the same amount, the 30 seconds, each time we look at it, it means that we are completely on our own, right?
Or maybe we have some follower, but just one, right?
Yes, so that's even more complex. So I'm doing
okay.
More complex one.
Okay.
So if you have no one in pgstat replication, and then you fail to connect to the monitor, and it's been 30 seconds that way, then we do what we call a demotion. We demote the primary. So we stop Postgres on the primary. That's
Why not converting it to read-only state?
Because at the moment, read-only is a restart. So you need to stop anyway.
Yeah, but we could restart in read-only mode and serve queries, at least read-only queries.
I suspect this for reasons of PG rewind.
Okay.
To make me rewind later.
So at the moment, yes, we stop.
Okay.
And so we wait for 30 seconds, and you can configure that, of course, but by default it's 30 seconds. And at 30 seconds, without any connection to either standby nodes or monitor, we shut down. And in parallel, because of what you draw on the slide, right? There is a red line there, and monitor and secondary are on the winning side of the network split. So they can talk to each other, but also the monitor is running auth checks. So the monitor has been failing to connect the primary for 30 seconds too, right? So the monitor knows the primary is not answering. And so after 30 seconds, the monitor is going to say, okay, I've waited 30 seconds. I know that the primary is going to shut itself down. So I'm going to promote the secondary now. And the secondary, it will receive the order to promote itself, and it will be promoted.
And which part, this is what extension? No, we don't have extension. What part of software shuts down the old primary?
Yes. So within PG Autofailover, there is a binary named PG Autocuttle. It's like PG control, but with automated. So it's PG Auto control. Okay. And you need to run that one instead of PostgreSQL directly. And this is going to be the parent process of Postgres and of another process that is doing the communication with the monitor. And so it's PG Autocuttle who's going to shut down Postgres, start Postgres, do a pgctl promote, PG rewind, PG bus backup. All of that, it's a PG Autocuttle doing it.
I see. Okay.
So basically, we are actually talking quite a lot of time. Yeah.
Oh,
so
sorry.
probably we need just to keep the things like manageable for people to watch later. One or two last questions. Maybe our audience actually have some questions. If you do have, write a comment in YouTube, or if someone on Zoom has.
If you don't write, I will ask questions because I always have. So you just described what is called shoot the other node in the head, right? Or some variation of it.
Variation of it. Yes.
My question is, what so far? How much experience this tool already gathered? How many setups or?
Yes, we have several customers who have been using it for more than a year in production. So they used early versions of it, and we keep improving. And so we have seen some bugs in production that we fixed already. And we have more and more open source users using it.
Did you have split brain?
No, the bugs we had, basically the worst case that I've seen is when we have a bug. So the monitor, it's a finite state machine, FSM. it has the state and it decides of the transition to another state. And the worst bugs that we have experienced in production is where the FSM is stalled. There is something that happens where it cannot decide to go to the next state.
Yeah, by the way, I saw it in code. It's well written in state machine. Like it's easy to read because it defines all the states and transitions between them. Yeah.
Yeah, that was the goal of the design. It's yeah, when we say simple and robust, it goes to the very lines of the code. Yeah, it's important.
Yeah. Do you have cases when more than say 5 replicas or 5 or more replicas were used? Because I have feeling that in these cases when we have a lot of standbys, replicas, this is exactly where you will experience, like probability of issues will increase for such.
Yeah. So I've done that, but in testing only. For now, I don't have feedback from production with that.
I see. Okay, so we don't have questions, do we? I mean, in the chat.
Yeah, and in chat there are no questions, but it was like very intensive amount of different things which we discussed.
Yes,
I would say.
Yeah.
As usual, we need, like with many of our guests, we need to plan a second episode somewhere in the future.
I would be very happy to participate again. Yes, if you want.
Yeah. Cool. Thank you so much.
With more concentration on, I don't know,
on some
SQL
cases
or failover or whatever.
Yeah, we could do I don't know if it's practical to do it, but I could share a interactive screen and we do a kind of a demo where we shoot the nodes and see what happens and things like that.
We actually like this format, so it would be cool actually.
Yeah, I agree. Yeah. So and you like, since it's open source, you invite I suppose invite everyone to try it, right? Or
of course, yes.
Or no?
Contribute.
No, it's very easy to get started with it, either from a package or if you're compiling it from source, it's as easy as compiling Postgres. And then we have a magic command. You do make cluster, and it uses tmux. So it opens a tmux session for you with several nodes that are already running, and you can play.
Interesting. So it itself opens tmux session. So I don't.
Yeah, it opens the tmux session for you with the monitor and the primary, secondary, another secondary, and an interactive shell.
I like this.
That's definitely better than Rep Manager.
Yeah. So you just make cluster and you play.
I like maybe for me last question. Are you ready for third-party comparison with other tools?
Yes. So for the comparison, I will say that if you try PG Autofailover, I encourage you. The first thing you should do is a failover, like a manual failover. There is one command that does a failover for you.
It's like switched over, like planned failover.
Exactly. Because we have the monitor and we track the state of every node. We know when the primary is down or when it's still alive during the failover. We have all the information. So it's the same command for us to do a manual or a manual failover. So to understand also the difference with other tooling, just make cluster and then you do pgAutoCTL, perform failover and see what happens. Yeah, that's my. I encourage you to do that. Yes.
Great. Okay, Dimitri, thank you so much. Thank you. It was interesting. I enjoyed it.
That was very interesting.
To all watchers who will watch later, don't forget to subscribe. I remind again, and all the buttons that you will find, please consider pressing them. So have a good weekend, everyone, and Dimitri, thank you so much once again. Bye.
Thank you.
Thank you, guys. See you. Don't forget the discount.
Yeah, don't forget the discount. Yeah, I will put it everywhere, of course. It was a joke that we want. We will put it. Okay, bye-bye.